How's it going, guys? Today in this video, we're going to be going over the Chapter 9 part of the final exam review. So let's go ahead and get started. So here we're going to say the transformations of g of x on the parent function f of x equals 1 over x. So remember the general equation for a transformed parent function of 1 over x. That's going to be a times 1 over x minus h all plus k. Or rather, I should make it 1 over b times x minus h all plus k. That's as good as it's going to get. So that's the general transform function for the parent function 1 over x, where a, b, h, and k do what they always do. All right, so for number 1, we have 1 over x minus 5 plus 5. That's going to be a translation to the right by 5 and a translation up by 5 as well. Then we have 3 times 1 over x. That's a vertical stretch. I'm going to do VS for short, vertical stretch by 3. Then we have negative 4, 1 over x. That's a vertical stretch by 4, and since that a is negative, it's also a reflection over the x-axis. Reflect over x-axis. And then we have negative 0.25, 1 over x. Again, the a is negative, so it's a reflection over x, over x-axis. And since our a value is still 1 over 4 or 0.25, it's also a vertical compression by 1/4. So we'll do VC vertical compression by 0.25 or 1/4. It's the same thing. Now we have 1 all over 0.25x. Remember, it's 1 over b, so if we have 0.25x, that means it's actually a 1 over 4, so our b is 4. So that's a horizontal stretch. I'm going to do HS for short, horizontal stretch by 4. And then we have 1 all over negative 4x. If we have a negative 4x, that means we have a 1 over 1 over 4. So that means our b value is 1 over 4. So it's a horizontal compression, HC for short, horizontal compression by 1/4. And since our b is negative, we reflect over y. So reflect over the y axis. All right. So let's keep on going. Number 2. We're going to decide if the data is inversely or directly related, and we're going to write an appropriate equation for each. Then we're going to find a missing value. So remember, if for an inverse function, that means I can multiply each value to get the same term. All right, so I can multiply x, y, and that will always give me the same value of a. And if I was a direct function or directly related, that means x, let's actually do y over x should equal a. All right, and we'll see exactly what that means when we go over 2a and 2b. So for 2a, we have our ticket prices and our total cost, T and C, and that's kind of going to be like our variables of x and y. So we're going to see if we get the same value if we divide or multiply them. So with 2a, if I divide c by t, 12 divided by 3 in the first pairing is 4. 28 divided by 7 is also 4. We don't know what that missing term is, and 36 divided by 9 is also 4. So we're dividing the variables and we're getting the same term every single time. That's exactly what we want from a direct. If we divide them, we get the same a term. So that means 2a is going to be direct. If we tried to multiply them, we wouldn't get the same thing. 3 times 12 is 36, and 7 times 28, I don't know what that is off the top of my head, but it's definitely not 36, so it cannot be inversely related. And since these are directly related, that means we're using the formula y equals a times x. So that's going to be our function, and we just need to solve for a. And which we already kind of did on 2a. We're saying c is going to equal a times t. Or in other words, y equals a times x. We're just using different variables. And we're going to plug in one pairing that we have to figure out our a. So when c is 12, we have some a value times our t of 3, or our a is 4. So our function is the total cost will equal 4 times your t. Or in other words, each ticket costs $4. All right. So now we need to figure out the missing value that we have right here. So we're just going to plug in 32 for c. We have our a value now. We can solve for t. So 32 should equal 4 times some t. Divide each side by 4. T equals 8. So the value is going to be 8. And now for 2b, we're going to see if it's inversely related. So if it's inversely related, that means our x times our y, or in this case, s times t, should all be the same term. So for the first pairing, we have some speed at a time of 80. We don't know what the speed is. We can't really check that one. But the next one over, we have a speed of 12 and a time of 50. That's 600. Then we have a speed of 15 at a time of 40. That's also 600. And then we have a time of 30 with a speed of 20. 30 times 20 is also 600. So we can see that every time we multiply our variables together, we're getting the same term of 600. And that's actually going to be our a in this problem. And since we're getting the same term every time we multiply, we can see that's going to be inversely related. Every time we multiply the two pairing together, we get the same a term. So that means 2b has to be inversely related. And we can see if we try to divide them instead, do t over s. 50 divided by 12 is not going to be the same thing as 30 over 20. So they're not directly related, because anytime you divide the variables, you're not going to get the same thing. But when we multiply them together for 2b, we're getting the same a term of 600. All right, so that means our function is going to be s equals our a value all over rt. All right, so the inverse function, we rewrite it down here too. It's going to be y equals a over x. Or in 2b's case, we can say s equals 600 over t. All right, we're just using different variables instead of x and y. We're using s and t. It's the same thing. All right, so now all that's missing is, for this problem anyway, is we need to figure out this s. So we're going to plug in 80 for t, and we're going to solve for s. So we have some s value will equal 600 all over 80. So we're going to divide 600 by 80, and when you do, you get that s equals 7.5. So the missing value in this case is 7.5. So for these problems, you check if it's inversely or directly related by using these properties right here, seeing if each pair of variables multiplies to the same thing or divides to the same thing, and then you use the respective formula to figure out your missing value. All right, number 3, we're going to find the horizontal asymptote by comparing the degree of the numerator and the denominator. So remember, this is the Bobo, Bottin, eats DC. So Bobo, Bottin, eats DC, where Bobo stands for bigger on bottom. The horizontal asymptote is 0. Bottin is bigger on top, none. Each DC is exponents are the same, divide coefficients. All right, so for 3a, we have x cubed minus 4 all over x squared plus 2. It's bigger on top. X cubed is bigger than x squared. So this is the Bottin part. So it's bigger on top, none. So horizontal asymptote, there's none. For b, we have y equals x minus 4 all over 2x minus 5. The exponents are the same. They both have a degree of 1. So this is each DC. Exponents are the same. Divide coefficients. So the leading coefficient of the top is 1, and the leading coefficient of the bottom is 2. 1 over 2 is 1/2. So the horizontal asymptote is y equals 1/2. Don't forget the y equals. If you just put 1/2, it's not going to be correct. That's just a number. While y equals 1 over 2 is an actual line. It's an actual function that we can make sense out of. All right. And now for 3c, we have -7 all over 2x minus 36. The degree of the top is 0, and the degree of the bottom is 1. That's bigger on bottom, the bobo. So bigger on bottom, 0. So that means our horizontal asymptote here is y equals 0. All right, so remember horizontal asymptotes, bobo, bottom, each DC. And do not forget to put the y equals. Just putting 1/2 or just putting 0 is not going to be correct. That's just a number. It doesn't make sense. Well, y equals 1 over half, or 1 over 2, or y equals 0. It's an actual line. It's an actual asymptote. Let's keep on going. Number 5, we're told the frequency f of a sound varies inversely. That's an important word. With a wavelength of, I keep forgetting what it's called. It's an upside down y. A sound signal that has a wavelength of 34 meters has a frequency of 10 hertz. What frequency does a sound signal of 120 meters have? So from the very beginning, we're told the frequency and wavelength are inversely related. So remember, if they're inversely related, that means it's going to be in the form y equals a over x. Or in this case, we're going to use f equals some a we don't know, all over, I think it's lambda, or the wavelength. All right. So what we're going to do is we're going to plug in this pair of points that they gave us. They already told us that when we have a wavelength of 34, that means we have a frequency of 10. So we can plug both of those in. So we have a frequency of 10. That will equal a all over our wavelength of 34. So that means our a value here will be 340. Multiply each side by 34, and we get an a value of 340. So that means our completed formula for this problem is f equals 340 all over, I think it's lambda. All right. So what we're asked for in this problem isn't to solve for a, but to solve for our frequency when our wavelength is 120. So that means we're going to plug in 120 for our wavelength, and we're going to figure out what our frequency is going to be. So we get f will equal 340 all over 120. And 340 divided by 120 is going to be approximately 2.83. So our answer is approximately 2.83 hertz. And let's just put f equals, or f is approximately, just to make sure it's fully correct. So f is approximately 2.83 when our wavelength is 120. All right. Let's keep going. Number 7, a student spends $20 a week for snacks at school if she is present all day or all 5 days. The total amount that she spends each week varies directly. Again, that's an important word. With the number of days school was in session. If she only spends $12 in 1 week, how many days was she at school? So first, we're told that it's directly related. That means we're going to be in the form y equals a times x. Y and x are directly related. So we need to solve for our a, and we're given one pair of points right there. When a student spends $20 a week for snacks, that means she gets she gets $20 a week if she was there for 5 days. There we go. All right. So what we're going to do is I'm going to put C for cost, or how much money she's spending on snacks. So C is going to equal some A times D, where D is going to be how many days she's actually present. So our C, that's her cost. We know if the student is in school all 5 days, she gets $20. So the cost, or the amount she has for snacks, is $20 if D is 5. So we can solve for A really quickly and get that A equals 4. Divide by 5 on both sides. 20 divided by 5 is 4. So A is going to be 4. So that's half the problem, because now we have our actual equation for this problem. It's C equals 4 times D. All right, so now we want to figure out how many days would we choose in school if she only got $12 1 week? So what we're saying is when D is 12, what's our C? So our C is going to equal our A of 4 that we know times, or sorry, not times 12. It's 12 equals 4 times D. Add that backwards. But the total amount of money she had was $12, and that's going to equal 4, which is our A, times our D. We're trying to figure out D when our C is 12. Sorry about that. All right. So we divide by 4 on both sides, and we get that D equals 3. So we're told it's directly related. That's why we use the form y equals A over X, or sorry, A times X. And we're going to use the variables C and D in this case. C for the total amount of money she spent on snacks. D for the number of days she was in school. And we're told she gets $20 a week if she was in school for 5 days. So we plug in 20 for C, 5 for D, since that's a pairing that they gave us. We solve for A. A is a constant, it stays the same no matter what. So our A is 4 in this problem. So that gave us our general equation of C equals 4 times D. And then we had to figure out what our D is going to be. How many days was she in school when she spent $12 1 week? So what's D when C is 12? We plug those into our C equals 4D, solve for D. So that's what we did for number 7. All right, let's keep going. On number 9, we want to rewrite the function in the form g of x equals a times 1 over x minus h plus k. So we're given f of x equals 3x minus 4 all over x minus 1. So to rewrite this in the form that we want, we're just going to divide 3x minus 4 with x minus 1. In the last video, if you watched it or at least went over it, we talked about how to do long division, how to do synthetic division. So that's what we're going to do here. All right. So we have 3x minus 4 divided by x minus 1. And we're going to figure out our quotient from here. So x goes into 3x 3 times, or in other words, 3 times x gives you 3x. So now we multiply all of x minus 1 with 3. So we get 3x minus 3. And now we're going to subtract the top from the bottom, or the bottom from the top. 3x minus 3x is 0. Negative 4 minus negative 3, or a plus positive 3, gives you a negative 1. So that right there is our remainder, since there's nothing I can multiply with x with to give me negative 1. So I get 3 plus negative 1 all over x minus 1. Remember, that's how you write your remainder. You put the remainder all over the the term you're dividing with, and that's going to be your remainder. That's our answer right there, or our quotient anyway. So when you divide 3x minus 4 with x minus 1, we get 3 plus negative 1 all over x minus 1. But what I can do from here is I can rearrange this to write it as negative 1 all over x minus 1 plus 3. And this right here looks very similar to the form that we want. The only thing that's different is that we want a 1 on the top right there. We don't want a negative 1, we want just a 1. But all we can do to fix that is just take out that negative 1 and put it in the front. Whatever's on top of the fraction, just take it, move it to the front. So we get negative 1 all over 1 over x minus 1. And that is going to be our answer. So divide it, and whatever's on the top of the a value, just take it out. And we get our answer right there. All right, let's go on to number 10. We're going to do the same thing, but in this case, we have a b in the bottom, or we're going to be doing it for b. So same thing, we're going to divide the top by the bottom. Negative 2x plus 4. So we're going to see how many times negative 2x goes into 4x, or in other words, negative 2x times 1 gives you 4x. That's negative 2. So we multiply negative 2 with everything right here. Negative 2 times negative 2x is a positive 4x. That's what we wanted. Negative 2 times a positive 4 is a negative 8. Now we're going to subtract both of these terms. 4x minus 4x is 0. Negative 7 plus positive 8 is a positive 1. So We have a remainder of 1, so we have plus 1 all over our divisor, what we're dividing with. So now we can rewrite this as 1 all over negative 2x plus 4 minus 2. I just rewrote it as the remainder in the front rather than the quotient. All right. And then again, this is very similar to the form that we wanted in. The only thing is that we want a coefficient of 1 in front of the x on the bottom. Not a negative 2x, we want it to just be 1. So what we're going to do is we're going to factor out a negative 2 from the bottom. So when we do, you have to factor it out from everything on the bottom. So it's 1 all over negative 2 times x plus 2. You take out a negative 2 out of positive 4. You're left with a negative 2. And all that plus, or sorry, minus 1, minus 2. All right. So you end up with 1 all over negative 2 times x minus 2. And that right there is going to be our answer. We put this in the form that we wanted. Our b in this case is negative 1/2. So that's how you're going to rewrite these problems. All right. Let's keep on going. Now we have around number 14. We're going to analyze the following functions. We're going to fill in the blanks, and we're going to figure out all its properties. All right. So anytime you have a problem like this, the very first thing you should try to do is factor out the top and the bottom. Don't cancel anything out yet, but factor it out. So I can factor out a 2 on the top to give me x squared minus 9 all over x squared minus 16. And the x squared minus 9 and x squared minus 16 are both perfect. They're both differences in squares. There we go. So I can factor it out a little more to give me x minus 3, x plus 3 on the top and bottom, or on the top, and x minus 4 and x plus 4 on the bottom. So that's my factored form. I haven't canceled anything out. And in this case, I actually cannot cancel anything out. So that means I have no holes. Holes, there are none. The holes only happen when you cancel out a term from the top and the bottom, or a factor from the top and the bottom. Vertical asymptotes, that's going to be whenever the bottom of your denominator equals 0. Or whatever, that's going to be what x value sets the denominator equal to 0. So in this case, x equals 4 sets x equals negative 4 equal to 0. And x equals negative 4 sets x plus 4 equal to 0. So that means both of those are our two vertical asymptotes. And remember, put x equals 4, x equals negative 4. Just putting 4 and negative 4 doesn't make any sense. Those are just numbers. They're not actual lines or actual asymptotes. Horizontal asymptotes, remember we talked about that in the previous problem. You look at the Bobo bond each DC. In this case, the top and bottom both have a degree of 2. So that means it's going to be the each DC. Exponents are the same. Divide coefficients. And the top has a coefficient of 2. The bottom has a coefficient of 1. So that means our horizontal asymptote is y equals 2. X-intercepts, that's going to happen whenever the numerator is set equal to 0. So whenever x values turn the numerator equal to 0, that's what's going to be your x-intercepts. So we see that an x value of 3 turns the whole top into 0. So that becomes 3, 0. And remember, x-intercepts are points. So it has to be some x value, comma 0. And the other x value that turns the top into 0 is a negative 3 because of x plus 3. So our two x-intercepts are 3, 0 and negative 3, 0. Y-intercept, that happens when x is equal to 0. So we just plug in 0 into our whole equation. So we get 2 times 0 minus 3, 0 plus 3, all over 0 minus 4, 0 plus, it's supposed to be 0 plus 4 on the bottom right there. All right, so when you do that, you get 2 times negative 3 times 3 all over negative 4 times positive 4. You work all that out, and we get that when x is equal to 0. So when the x value of your point is 0, you have 9 all over 8. So our y-intercept is 0, comma 9 over 8. Our domain in set notation, That's just going to be every value other than our vertical asymptotes in our holes. So in this case, it's every x value such that x does not equal our vertical asymptotes of 4 and -4 in our holes, but we don't have any holes, so we don't have to worry about it. Just every x value such that x doesn't equal 4 or -4. In interval notation, it's going to be the same thing from -infinity up to one of our terms that we cannot equal, so -4, union -4 to the other term we cannot equal, union 4 to infinity. And that's our domain in interval form. All right. Now on to 14c. We have x squared plus 8x plus 12 all over x plus 2. So same thing, we're going to factor this out first. And when we do, you should get x plus 2, x plus 6 on the top. And the bottom's already factored out at x plus 2. So we see we can cancel out this x plus 2 from the top and bottom. That's what we do. You cancel out from the top and bottom, and we're left with x plus 6. And since we canceled out an x plus 2 on the top and bottom, the 0 that comes from that factor is going to be the x value of our whole. So x plus 2, the 0 that comes from that factor is -2. And now we need to figure out what our y value of that whole is going to be. So we take this -2 and plug it into our simplified expression. So -2 into x plus 6. We plug a -2 into that, we get a +4. Right, -2 plus 6 is +4. So plug in the 0 that comes from the canceled factor into the simplified equation, and you get the actual point of your whole. So we have -2, 4. Vertical asymptote, it's going to come from the denominator of the simplified term. We don't have a denominator in this case. If we don't have a denominator, we can't have a vertical asymptote, so it's none. A horizontal asymptote, so it's x plus 6 all over 1, technically. So we're going to look at our Bogle bond ETC, and we said if we're bigger on top, that's none. That's the bottom part. Degree of 1 on the top is bigger than degree of 0 on the bottom. So it's the bottom bigger on top, none. So we have no horizontal asymptote as well. X-intercept, we said that happens. We said the top or the numerator equal to 0. So in this case, we get an x value of -6, and x-intercepts are a point, so it becomes -6, 0. Y-intercepts happen when x is equal to 0, so plug in 0 for x. That gives you your y term, so you get that y equals 6 when x is 0. So when x is 0, our y-intercept or our y value is going to be 6. So our y-intercept is 0, 6. Our domain in set notation will be every x value other than our vertical asymptotes and our holes. We don't have any vertical asymptotes, so it's just going to be every x value such that x does not equal the x value of our hole, or just -2. And now interval notation, we're going to go from -infinity up to our first point that we cannot equal, which is -2. And then from -2 to infinity, since there's no other point that we cannot equal. And that's how you kind of break down these type of functions. All right, let's keep on going. 15, fill in the blanks and graph. We have g of x equals 2 times 1 over x minus 3 plus 4. So our a we see is 2, our b is 1, our h is 3, and our k is 4. And remember our transformation rule, it's bx plus h, ay plus k. And that's how we're going to figure out our 2 points right here, our 2 new points. So our vertical asymptote, that always happens when x equals h. So in this case, it's x equals 3. Our horizontal asymptote is y equals k. So in this case, y equals 4. And our 2 points, -1, -1, and 1, 1. We're going to plug both of these into our transformation rule, which in this problem will be x plus 3, comma, our a of 2, y plus 4. So you're going to plug in -1, -1, and 1, 1 into our transformation rule. And when you do, you'll get the point 2, 2, for the first one, and the 0.46 for the second one. Just plug in your x and y into the transformation rule that shoots you out your new points. All right, so we're going to graph this really quick as well. So first thing we always want to do is graph our asymptotes. So an asymptote at x equals 3, and asymptote at y equals 4. And now our 2 points of 2, 2, that'll be right over here, and 4, 6, right over there. And our function will look like this, where it basically just gets really close to the asymptote, but never touches or crosses. So that's more or less what our graph is going to look like. So now let's figure out our domain and our range. So our domain is always going to be based around our h. So it's x is less than h, or it shouldn't be a comma, it should be or x is greater than our h. There we go. So in this problem, x is less than 3. I don't know why I keep putting commas. X is less than 3, or x is greater than 3. Set notation. Every x value such that x does not equal our h value, which is 3. Don't actually put the h. I'm just putting this so you actually know that it's based on the h. Every x value such that x does not equal 3. All right? Or in this case, it's always going to be h. So in this case, 3. Interval notation, again, is going to be based on the h, so negative infinity up to your h value, which is 3. Then union 3 to infinity, or h to infinity, but in this case, it's 3 to infinity. Our range is going to be very similar, but it's going to be based around your k. So inequality, y is less than k, or y is greater than k. So in this problem, y is less than 4, or y is greater than 4. Set notation, same thing. Every y value such that y does not equal our k value of 4. In interval notation, negative infinity up to our k value of 4, union 4 to infinity. All right? So number 17, write the equation of the function whose graph is shown. So we're given our points, we're given our asymptotes, and we need to figure out what our equation is going to be. Right? So I see that these two green lines are our asymptotes. So I see I have a vertical asymptote at x equals 1 and a horizontal asymptote at y equals 4. And remember, vertical asymptotes is x equals h, so our h is 1, and horizontal is y equals k, so our k is 4. So we have our h and our k, and we have 2 points over here, 2, 7, and 0, 1. So we also have our x and our y. So we're going to plug all these in, and we're going to figure out what our a is going to be. All right? So our y, I'm going to use the point 0, 1. So I get the point 1 equals our a value, which you don't know, times 1 all over x minus h. So our x for 0, 1 is 0, minus our h value of 1, all plus our k value of 4. So 1 equals a times 1 over negative 1 plus 4. Solve it out, minus the 4, negative 3 equals negative a, or a equals 3. So I have my a, h, and k. So my equation is g of x will equal our a value of 3 all over 1 over x minus h, which is 1, plus our k value of 4. All right? And I think that's it for the video. Yes, it is. We do post a completed key of the whole review online. Same thing with previous note packets. So if you want to go over the full notes, the completed notes are already online on Canvas. You can go through that as well. And hopefully this video helped, guys.